Lesson 32-2 is going to talk about sectors and arcs. So what we're going to be doing today is coming up with formulas and applying those to find the area of a sector, and also coming up with a formula and using it to find the measure of an arc length. So we're starting in your Springboard book, page 467. Okay. So let's look at this picture here. It says Lance told the landscape architect he would like the garden to resemble a colorful parachute with different flowers in alternating areas of the garden. The landscaper developed a sketch of the garden below here. So you can see we have our circle and all these different parts that he's going to separate using different kinds of flowers. Now in number 1, it says the circular garden is divided into 8 equal parts. What portion of the total area of the circle is each part? So if we have our whole circle, okay, so they're saying what is one portion then? So if we just look at maybe this portion, what portion of the total area is that? Well, that's just 1/8 of the area, right? The whole circle is divided into 8 equal parts. Now, we didn't do this previous section in the book, but it said that Lance would like the diameter of the circle to be 20 feet. Okay, determine the area of each sector of the garden. Well, we can kind of use the fact that we know how to find the area of an entire circle. We can use our area formula, which is pi r squared. Okay, so let's look at that. So if our diameter is 20, that makes our radius 10. So pi times 10 squared. Now this would be the area of the entire circle. So let's just use our calculator here. 10 squared is 100. And I'm using the pi button to get the most accurate answer here, but we should get 314.159. Okay. Now that's the area of the entire circle. So if I want just the area of one section, that's what it says, determine the area of each sector of the triangle. Well, or the circle, I would just have to take that and divide it by 8, right? To get just one piece. So let's do that in our calculator. Divide that by 8. And there is our answer, okay? So that is one way where we can find the area of a sector, okay, of a circle. So if it's divided into equal parts, then you can do that. Now the circle won't always be divided into equal parts. So we are actually going to come up with a formula that'll help you find the area of a sector of any circle, okay? Moving down here, it says, what's the measure of the central angle of the sector in part A? Now we know these are all the same triangles here. They're all regular triangles there in your circle. So if it's divided into 8 parts, well, we know a whole circle is 360 degrees. If we divide that circle into 8 parts, what's the measure of one central angle then? Well, 360 divided by 8 would give us 45 degrees. So in part D, it says to write a fraction that is equivalent to our answer in part A that would have a denominator of 360. Well, 45 degrees divided by 360. If we use our calculator to reduce that fraction for us, hit math, enter, enter. You see we get the same fraction from number 1A, which is 1/8. Okay, so that leads us to our first formula. So this is the formula to find the area of a sector with a central angle of n degrees and a radius of r. Okay, so what you do is you take your central angle and divide it by 360. That'll give you your portion of your circle that you have, and then times that by the area formula of the entire circle, okay, which is essentially the same exact thing here I did in B, where I took the area of the entire circle and just divided it by the 8 parts. So that's what you're going to do here, except you're using n degrees from the central angle. So what portion of the circle do you have? Times that by the entire area of the circle. Okay. So I'm actually going to jump ahead here. I put in an extra problem at the bottom of this page, so you might need to pause here for a second and copy it in. But if we have this sector, okay, AB, okay, so it's this bolded area here. Can you find the area of that sector for me? So remember, your area formula is your central angle over 360 times our area formula for a circle, pi r squared. So it looks like your central angle there is 135. Your radius is 6. Can you find the area of that sector? Okay, if you did everything right, I got 42.4 feet squared. So as long as your answer is close to that, we could have rounded a little different. Okay, or if you use 3.14 instead of the pi button, your answer will be a little different, but it should be close enough. Okay. The last thing we have to talk about today then is arc length. So here's your circle of our garden here, our pattern. I just copied it over. But it says determine the arc length of each sector of the garden. Now, arc length, okay, is the distance between 2 points along a section of the curve. A little typo there, of the curve. So what they're talking about with arc length is if I pick 2 points on this circle here, arc length is talking about what's the distance between those 2 points. Okay, so we have to think about how to find the distance of the whole circle and then just narrow it down to just that 1 point. So if we're finding the distance around the circle, what are we actually finding? Okay, so for that, we'd be finding circumference, right? Circumference is like the perimeter of the circle. So we can use that using 2 pi r or pi times diameter. That's how we find circumference. Now remember, they told us our diameter here for this picture on page 1 was 20. So I'm probably going to use pi times diameter since we have that. So again, using my calculator, 20 times pi would be our decimal, 62.8 roughly. So if we want to find the area of just one of those pieces, okay, the length of just one of those kind of little sections, we would just have to divide it by the sections we have, which was 8. Okay, so we should get this answer. So let's round that to 7.9. And I believe it was feet. Okay. So that's the difference between the area of a sector. Area of the sector is talking about the area of that entire piece and then it's filled in. Arc length is just talking about the length along the curve, okay, between 2 points on a circle. Okay, so an equation that we can use, okay, every time would either be one of these, okay? Basically, it's just your circumference divided by the portion of the circle you have. So if you take your central angle, n, divided by 360, that should give you your portion of your circle, and then just times that by the circumference. Okay, so we know this is standing for circumference. Now, this formula is just a simplified version of that. They're taking the 2 and simplifying it with 360. That's why it's just 1 pi over 180. Honestly, doesn't matter how you find the arc length. Just pick a formula you like best. Okay, and again, you could always do n over 360 times pi times diameter as well. That's another formula that you can use. So you have 3 different options here for a formula of an arc length. So I'm going to have you guys try. It's the same picture here that I did on the bottom. But now I want you to find the arc length of AB. So what is this length along this circle? Okay, so if you did it correctly, you should have gotten 14.1. So you take your central angle, right, 135, and divide it by 360. That'll give you your portion of your circle. And if you times that by, like, let's say 2 pi times 6, if I did 2 pi r. Okay, that's how you get your answer there. So you can do this all in a calculator at once. You can kind of simplify things as you go along, but in the end, it shouldn't necessarily matter. Just as long as your answer is close, we'll be good. Okay, so the only other thing I just want to talk about really quick is the difference between arc length and the area of a sector. Okay, but remember, arc length is in linear units because that's like your perimeter, just your distance from one point to the other. Whereas the area is always in square units. Okay, so just kind of look at what they're asking you to find. A length would just be a short distance from one point to another. Area of a sector, think area, pi r squared, area of a circle. Okay, it's going to have those square units. Okay, so we will practice more problems together in class.